Hello and welcome to lesson number 1 of Unit 1 Functions in our grade 11 University College math class. So this is really the beginning of the course proper. The course is called Functions and Applications, and we're going to dig into functions right now. So in order to understand what a function is, we need to first understand what a relation is. And it says right here in part A, a relation is defined as an identified pattern or relationship between two variables. And this isn't new to us. We've been working with relations since grade 9 and before that really. Relations can be represented in a variety of ways as a set of ordered pairs, like points that you would see that we would graph on the coordinate plane, table of values, graph, equation, or mapping diagram. Now, mapping diagram is probably the one that you're least familiar with, so let's just have a quick look at a mapping diagram seen right here. These are ordered pairs here, by the way. 1, 2, 5, 3, 9, 4, 7, 1. That's a mapping diagram. Or sorry, those are ordered pairs. And from these ordered pairs, we are going to make a mapping diagram. So the mapping diagram, the way that it works is it is sort of an input-output kind of vibe, where this is like your input, which is our x value, and then we have our output, which is our y value. So when we have an input of 1, which you can see right here, there's our 1, it goes across and connects with a line to 2 on the output side. And that's our first point there, 1, 2. Let's have a look at another set of pairs. Here we have 5, 3. So let's do this one here in purple. 5 is our input value. There's 5. And it goes across to 3 on the output side. Let's grab another color here. We'll do green this time. So now we're going to do 9 to 4. So there's 9 on the input side. There's 9, goes over to 4 on the output side. Oh, that doesn't look like a 4. There we go, it's a little closer. And last but not least, we have 7 and 1. 7 is our input value, goes over to our output value of 1. Now, this seems like a little bit of a bizarre configuration for this, but remember that when you're making a mapping diagram, you want your numbers to appear in their little bubble in descending order. So it's more important to sort of look down the line and say, so my input values are 1, 5, 9, and 7, so the correct order would be 1, 5, 7, 9, and then do the same thing with the output values. That is a characteristic of a mapping diagram, so now you see what it looks like. This is one way that you can express the relationship between two variables, in this case an input and an output, an x and y if you prefer, however you like. Let's move down the line. These are all looking quite familiar now. This is again ordered pairs that we have up here, and we're going to express these in a table of values. Pretty straightforward. So we have 1 and 3 from 1 and 3 here. Again, x and y, input, output. We have 4, 2. We have 3, 2, and we have 6, 5. Again, just another way to represent the relationship between this input, output, input, output, input, output. And last but not least, we have a graph. Again, a set of ordered pairs or points. We're going to put them on a scatter plot, so I'll just grab a different color and let's just pop them on the graph here. So we have point 1, 4. Again, just for those who need to recap, there's the origin. We go over 1 and we go up 4, and that's where we put our point. So that's how we go about graphing. Let's erase that stuff, leave just the points. So we have 1, 4, 3, 1, 2, 3, 2. We have 5, 4, 5, 4 is up here, and we have 3, 1, so 3, 1 right there. So visually, again, on a graph, it is a relationship between the two variables, the x as it pertains to y, input and output one more time. So this is a relation. Functions are a subset of relations, and their defining characteristic, and I'm going to highlight it here because you're going to hear me say it an awful lot and I want it to get in your brain. It is that each input variable corresponds to exactly one of the output variable, which means that when you put something into a function, it always spits out the same thing for the same input value. So you can see that here visually when if I put just a regular old x value in, call it x1, it's always going to spit out y1. It will never spit out something different like y2 or y3. It's always going to spit out the same predictable value. That's a function. Similarly, you can have two different inputs that go to the same output. That is a function also, as long as x1 always spits out y1 and x2 always spits out y1. It just can't change. That's the thing. It has to be predictable and reliable. This one over here is not a function, where if you have the same input, x1, and if at one time it spits out a y1, at other times it spits out a y2, this, as the graphic says, not a function. So again, just to say it, a function is a subset of types of, it's a type of relation where for every input you have one and only one output. There's no change, it's always going to be the same thing. So let's have a look at this in terms of the mapping diagram that we did above. 1 and 2 up above, or a and b, are functions. And we can see that because when we put, let's keep the highlighter going I guess, when we put 1 in, we only ever get out 2. When we put in 5, we only ever get out 3. When we put in 7, we only ever get out 1. And when we put in 9, we only ever get out 4. So this is a function. F for function. Yes. And this one over here, same idea. You put in a 1, spits out a 3. You put in a 4, spits out a 2. You put in a 3, spits out a 2. And again, this is okay. As long as 4 always spits out 2 and 3 always spits out 2, there's no problem. It's when they change. If 4 spits out a 2 and then all of a sudden it spits out a -6 or something, that's when it stops being a function. But right now, every input has one and only one output, and that is what makes it a function. However, over here, this is not a function, and we're going to go have a little look down and make a mapping diagram to sort of see how this would look, because this, visually, there's a way to tell that this is not a function, but let's just jump down. So we have 1, 4, 3, 2. I'm just going to write down the numbers here on the side. So 1, 4, 3, 2, and that way I can get them in the right order. 5, 4, and 3, 1. So 5, 4, and 3, 1. So if I'm going to do these in the proper order, descending order, I have 1, I have 3, and I have 5. No need to write in the repeat. And over here I have 1, 2, and 4. Oh, I should have left that in there so I can see the points. Let's do that. 1, 2, and 4. There we go. So our first point is 1 to 4. So that looks okay. One input, only one output. That one's okay. Still a function so far. And then we have 3 to 2. That's straight across. The arrows are also important when you're making the mapping diagram here, that you're going from input to output. So at this point, 3 only spits out a 2. No problem. Next point down, 5 to 4, or 5, 4. There it is. That's okay. We can have two inputs that go to the same output. That's not a problem, as long as 5 doesn't spit out something different. However, it's this last point here that's going to mess it up for us. I'm going to do this one in red for you done messed up. So we've got 3 to 1. And there is our culprit. Because what you have here is sometimes 3 is spitting out 1, but sometimes 3 is spitting out 2. This is what makes it not a function. So this is not a function because the input value 3 goes to two different values, 1 and 2. So not a function. Now visually, how can we see this? Because we drew a mapping diagram. Admittedly, that's a bit of a pain. How can I do this visually? Visually, we can tell if something is a function by using a tool that was developed called the vertical line test, or the VLT if you prefer. It's an easy way to determine whether something is or is not a function. And the way that it works is you're going to draw a vertical line through a function, or I guess through a relation. And if it only intersects the graph at one point or no points, it's a function. But if it hits the graph of the relation more than once, then it is not a function. So let's have a look at this first one here. Here's just a parabola opening up. I'm going to draw a vertical line through this. Here's a vertical line, straight up and down. There it is. How many times does it hit the function? Well, it only hits it once. So that's, or does it hit the relation? It's only once so far, so that makes sense. Let's do another one maybe down here. Again, only hitting it once. As long as the vertical lines are only hitting the relation once, it is a function. So we would say that this one, this parabola, does indeed pass the vertical line test, and that makes it a function. That's the way it works. Let's have a look at this sort of rotated parabola. Let's draw some vertical lines. So if I draw a vertical line over here, hasn't hit the function at all, or hasn't hit the relation at all, so it is still a function at this point. if I draw a vertical line, it's a terrible vertical line, there it is, and as you can see here, it hits the relation twice. So automatically this means it does not pass the vertical line test. It fails the vertical line test, and on top of that, this is not then a function. I was trying to draw one here so that it hits basically just right on the tip of this parabola, so it would only hit once. Again, it can have instances where it hits no times or once. As soon as it hits twice, the whole thing's over. So you want to do a few different vertical lines here to make sure you're getting a good representation of the whole relation to see if it's a function. Let's try a straight line. So this is the actual relation that we're looking at. Let's draw some vertical lines through it. As you can see, no matter where I do it, it's only hitting once. That means that this does pass the vertical line test and it is a function. Over here, this is a sine function. You're going to see this in Unit 5. Let's draw some vertical lines through it. And as you can see, no matter where we go, we're just hitting once, 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 once. So never more than that. Does this pass the vertical line test? It does, and it makes this a function. And you can see why using using straight lines, parabolas, and sine functions. All three of these are units that we're going to be doing in the course. All three of them are functions. That will hopefully just inform that this course, which is called Functions and Applications, you'll be using functions an awful lot. And that's the end of the lesson here. You have some homework, and the homework is really about recognizing when things are or are not functions. I will say that using the vertical line test is only a satisfactory defense of whether something is or is not a function if you've been given the graph. If you've been given a mapping diagram, or if you've been given a table of values or something like that, you would have to say that something is or is not a function based on the fact that it has an input that goes to one, or in the case of it not being a function, more than one output. So that's lesson number 1. The homework here is listed at the bottom. If you have any troubles, again, this is a new big concept, so give yourself some time to sort of mull it over and get it in there. Any questions, reach out to me via email, in person, in our video chat in the class. Any way you can get a hold of me, please do it, and we'll get you through this first lesson's homework. Good luck with that, and we'll see you in lesson number 2.